right, so I entered all that into my calculator to get the quadratic regression, and I got negative 0.02. Does it say how many to round to? Okay. 3, 5, x squared, plus 2.1011x minus 15.9062. Okay, so that's my regression model. And then it says, at what speed is the gas mileage the greatest? Round to the nearest mile per hour. And so I think I'm going to use the calculator to do that. So I'm going to plot that into my y1, and I get negative 0.0235 x squared plus 2.1011x minus 15.9062. Let's make sure that's all right. I think that looks good. I'm going to graph that. Now I probably need to make sure my window makes sense here. And so if I think about the values that I have there, my x's were going, let's just do like 0 to like 70, because that's about how high my gas mileage was, or my speed was. And then the mileage was, I don't know, maybe I'll go up to like 40. So we'll do like 0 to 40 on gas mileage. We'll see how that looks. Okay, awesome. So I've got a nice graph there, and it looks kind of like this. So I went up to 70 here and to 40 here. So if you do that window, you'll get something that looks like this. And it kind of stops there. So I'm looking for this point. So I'm going to find that, calculate that maximum. So I go to the left, and then I scroll over, and I go to the right. And it looks like that is at 44.70. And that is a speed. Those are miles per hour. So that is the gas mileage is the greatest, around 44.7. So if I round to the nearest mile per hour, that's 45 miles per hour. And then what is my maximum gas mileage? And so I look just for the y coordinate of that. It's 31.05. Oh, round to the nearest mile per gallon. So 31 miles per gallon. Okay. Determine the end behavior of that polynomial function and explain how you arrived at your answer. So the first thing I want to look is that it's an odd function, and so I know that odd functions, the ends are going in opposite directions, and since we have a negative in front, the end behavior is going to be doing this and that. How do I indicate that? I'm not sure what notation you use to indicate that. Okay, for finding the zeros and stating their multiplicities, I can see that this corresponds to the 0 of x equals 0, and the multiplicity of that is 2 because it's squared there. And then I have the next one is x equals, so from this one I get x equal 5, and the multiplicity is 3 on that one. And then this one right here is giving me the 0 x equal negative 2, and the multiplicity on that is 1. And then this one right here gives me the 0 x equal negative 5, and the multiplicity on that is 5. So you're looking at that power to give you the multiplicity. So we have 4 zeros, and so if I want to list them all out together, I have x equals 0, multiplicity 2, x equal 5, multiplicity 3, x equal negative 2, multiplicity 1, and x equal 5, multiplicity 5. Okay, so those are our 4 zeros. Use the intermediate value theorem to determine, if possible, if that function has a 0 on the interval -1 to 1. Okay, and so what I want to do is I want to look at the, I want to look at f of -1 and f of 1 and see what we get. So if I plug in -1 into that, I'm going to get 2 times -1 cubed minus 5 times -1 squared, and then plus 15, and then plus 20. So I get something positive, which is 28. So this is positive. And then if I do f of 1, I'm going to have 2 times 1, and then minus 5 times 1, and then minus 15 times 1, and then plus 20. So I get positive 2. Okay, and so in order to use the intermediate value theorem, I need to have, I know it's going to have a 0 on the interval if we have a sign change on that interval, and we don't here, so so the intermediate value theorem does not apply. So the next one, I want to sketch that polynomial function. I can see its factored form is here, and then I need to think about in behavior, zeros and multiplicities, and y-intercept. Okay. So the y-intercept, I can plug in p of 0. If I plug in 0, I get 0 minus 0 minus 0 plus 0 minus 48. So that's my y-intercept. The zeros are x equal 2 multiplicity 2. That means it's going to touch and turn at 2. X equal 4 multiplicity 1. That means it's going to cross at 4. And x equal -3 multiplicity 1 as well. So it's going to cross at that one. And then for the end behavior, I can see it's a quartic and it's positive, and so the end behavior is going to be like that. Okay, so let's see if we can sketch this dude. Okay, so it's going to intercept here down at -48 there. And then at 2, it's going to touch and turn. And then at 4, it's going to go through. And then at -3, it's going to go through. So if I were to graph this, I would say it's doing something like this. So there's my graph. Long division of polynomials. So I can divide these two. So let's see, I'm going to need a lot of space for that. Let me erase some things. I'm going to erase my graph I just made. Alright, so let's see if I can copy this all down. So I have here 6x to the 4th, maybe I'll do it over here. 6x to the 4th minus 4x cubed plus 4x squared minus 10x minus 25. And I'm going to divide that by 2x squared minus 3x plus 5. Okay. So the first thing I want to do is I want to look at this term, and I want to think about what do I need to multiply this term by to get that. And so when I think about that, I can see that I'm missing a 3 and an x squared. So I can put 3x squared up here. And then I'm going to multiply that 3x squared by each thing here and see what I get. So I'm going to get 3x squared times x squared. 2x squared is going to give me 6x to the 4th. And then I'll have minus 3 times 3 is 9x cubed. And then plus 15x squared. Then I will subtract all of that. And so when I do that, those two add to 0. I'm going to have 4x cubed plus 9x cubed, so I'm going to get positive 5x cubed. And then 4x squared minus 15x squared, so that's a negative 9x squared minus 10x. I'll go ahead and bring that dude down. Okay, next thing I want to do is I want to look at this guy here and see what do I need to multiply that guy by to get the 5x cubed. And I can see that it's going to be 5 halves x. And so when I multiply 5 halves x back by each of those things, I'm going to get 5x cubed minus 15 halves x squared and then plus 25 halves x. Okay, and then I'm going to subtract all of that, and when I do that, I'm going to get, let's see, negative 9 plus 15 halves is negative 3 halves x squared, and then negative 10x squared minus 25 halves is going to be negative 22.5 x, and then minus 25. Okay, good. And so then what do I need to multiply 2x squared by to get negative 3 halves x squared? And so I think it's going to be minus 3/4. And so when I multiply 3/4 by 2x squared, I get negative 3 halves x squared. And then negative 3/4 times that, I get plus 9/4 x. And then negative 3/4 times 5 is negative 15/4. And I want to subtract all of that. And so I'm going to get negative 22.5 minus 9/4 gives me negative 24.75x. And then negative 25 plus 15/4 gives me 21.25 minus. Okay, and so so then the quotient is this top part here. It's called the quotient. And this part down here is called the remainder. Okay. Then the next thing, I want to use synthetic division of polynomials to divide that guy out. So I notice that there's no x to the 4th term there, so I'm going to have to make sure I skip a spot. So I've got 4 here as my 0, and then I'll have 2, 0 for the x to the 4th, to negative 26 for the x to the cubed, negative 14 for the x squared, negative 33 for the x term, and then negative 28. Okay, so I drop the 2 down, and 4 times 2 is 8, and then I add those, I get 8. 4 times 8 is 36. 32 minus 26 gives me 6. 4 times 6 is 24. Minus 14 is 10. And then 4 times 10 is 40. Gives me 7. And then 4 times 7 is 28. And when I add that, I get 0. So here the quotient is going to be given by those coefficients. So the quotient is, so see, that's the x term, x squared, x cubed, x to the 4th. So 2x to the 4th plus 8x cubed plus 6x squared plus 10x plus 7. And remainder is right here, and it's 0.